Welcome to the deep dive. Today, we're going to be looking at BlockSmith's Pleone CyberSecurity Suite.
Oh, cool.
You've given us quite a mix here.
Yeah.
Marketing materials, technical documents.
Sounds like fun.
Even a presentation by the founder himself.
Oh, wow.
Yeah, so I think our mission is to figure out how Pleone tackles these modern cybersecurity threats, especially ransomware. And I'm really interested in their approach to passwords and key management.
Yeah, they're doing some really innovative stuff over there.
They are.
It seems like BlockSmith is really taking a ground-up approach to cybersecurity. They're not just like offering another firewall or antivirus or something like that.
Right.
It seems like they're rethinking the whole foundation of how we protect our digital lives.
Yeah, you're right. And their tagline is Pleone, the mother of all protection.
Oh, wow.
Pretty bold.
Yeah.
The material highlights Pleone's modular design.
Okay.
So you can pick and choose which tools you need.
Right.
They've got a lifetime purchase promotion going on, which is tempting.
Uh-huh.
They've got modules like LCY for application security.
Okay.
Zito for secure authentication, and WISEM, which stands for your unbreakable and unphishable password system.
Catchy.
And one more thing. They're also pushing a ransomware solution soon called RAIL.
Interesting.
Ransomware Elimination Protection is what they're calling it.
Wow, that's
No, that's something I want to hear more about.
Yeah, the timing of that is really interesting.
Right.
Especially given the rise of all this ransomware attacks. I mean, a lot of the traditional approaches to ransomware are reactive and not always effective. So a solution that actually aims to eliminate or seriously reduce the threat, that could be a game changer if it works as well as they say.
Absolutely. But let's not get ahead of ourselves. Let's look at the technical details first.
Okay.
So the BSU documentation technology-deepdive.pdf document.
That's a mouthful.
Yeah, it is.
Okay.
It explains the core issue that while we're good at encrypting data these days, the keys and passwords that protect that data are often vulnerable.
Yeah, it's like having a high-tech safe with a really weak lock.
Exactly. The
document actually illustrates this with a data protection paradox diagram.
Okay.
And it shows that the encrypted data might be really secure, but the traditional methods of storing the keys, those are often the weak point.
Okay.
Passwords can be cracked, stolen, or even accidentally revealed.
Right. That's a great way to visualize it.
Yeah.
It shows how the strength of your system really hinges on the weakest link. So how does Pleone address this vulnerability?
Well, Pleone takes a holistic approach.
Okay.
It addresses not just data security, but also identity and system security. The document really emphasizes what they call the unbreakable security principle.
Right.
And they have a cool visual representation of it using different colors to show how the components all work together.
Oh, yeah, I'm looking at that diagram.
Yeah.
It looks like they're combining passwords, keys, biometrics, all these different elements to create a multi-layered defense.
Right.
And they even mention an N+1 secrets guarantee.
Yeah.
And 3-factor authentication.
That N+1 secrets guarantee is a fascinating concept.
Tell me about it.
So instead of just focusing on making each individual component super secure, they're building redundancy into the system itself.
Okay.
So even if an attacker manages to compromise some secrets, they won't have enough to break the system as a whole.
So it's like having multiple blocks on a door.
Exactly.
Even if someone picks one, there's still more to get through.
Right. And then their 3-factor authentication goes beyond the typical something you have, something you approach.
Okay.
They're integrating things like keystroke dynamics and real-time threat intelligence to create a more dynamic and responsive security layer.
So it adapts.
Yeah, constantly adapts to the situation and the user's behavior.
That makes sense. It's not just static passwords and tokens anymore.
Right.
It's about analyzing behavior and adjusting security in real time.
Exactly.
Okay, so we have this overall understanding of Pleone's approach. Now I'm curious about the specifics.
Okay.
Let's start with YOUP.
Okay.
Your unbreakable and unphishable password system.
All right.
How do they make passwords unbreakable?
Well, first, they allow for much longer passwords, including emojis.
Okay.
This increases the possible combinations.
Right.
Which makes brute force attacks really difficult. And they use these longer passwords to derive a 64-byte cryptographic secret.
Okay.
Which is then used to generate a complex password that integrates into existing systems.
So you're saying I could finally use those ridiculously long passwords I've been dreaming of?
Yeah.
The ones with inside jokes or emojis?
Yeah.
And they would actually be more secure?
Exactly. It leverages how we naturally remember things.
Okay.
Stories, emotions, personal connections. The longer and more unique, the better.
That's pretty cool, but what about all those websites and services that still have password length limits?
Right.
How do you handle that?
That's where their hidden multi-factor authentication comes into play.
Hidden multi-factor authentication?
Yeah.
What's that?
So it's a really clever way to enhance security without creating extra steps for the user.
Okay.
They use a high-entropy seed, basically a secret piece of information, to strengthen password generation in the background.
Okay.
The user doesn't even know it's happening.
So it's like an invisible security boost.
Exactly. It's always there reinforcing the password without any extra effort.
And on top of that, they have adaptive security offers.
Yes.
Okay.
So the system analyzes things like keystroke dynamics and uses real-time threat intelligence to adjust security on the fly.
Okay.
So if it detects anything suspicious...
Like what?
Like unusual typing patterns.
Oh.
Or a known attack signature. It can immediately ramp up the security.
So it's like a security system that's always learning and adapting.
Precisely.
That's impressive.
And this leads us to one of the most innovative aspects of Pleony.
Okay.
Their keyless security approach.
Okay, keyless security, what does that even mean?
So it's about how they manage cryptographic keys.
Okay.
Traditionally, keys are stored in vaults, either physical or digital, which are potential targets for attackers.
Yeah.
Pleon's approach eliminates the need for vaults completely.
Interesting. So how do they do that?
They derive the keys dynamically from 3 factors.
Okay.
A seed, a password, and non-static biometrics.
Okay.
Think of it like a recipe.
Okay.
Where you need specific ingredients to bake a cake. The cryptographic key is the cake, and the ingredients are those 3 factors.
Got it.
The key is only reconstructed when it's needed.
Okay.
And then it's immediately deleted after use.
So instead of storing the key in a vault, they recreate it on demand using these 3 factors.
Yes, and this drastically reduces the attack service.
I can see how...
Even if an attacker compromises one of the factors, they can't do anything with it because they need the other 2 to reconstruct the key.
Right.
And because the key is never actually stored, there's nothing to steal.
That's brilliant. It's like a self-destructing key that only exists for a moment. But this keyless security concept...
Yeah.
Does it just apply to keys?
Well...
Or does it extend to other sensitive data as well?
You're thinking along the right lines.
Okay.
They apply this vaultless approach to what they call non-human identities, or NEDs.
NEDs.
Yeah.
Okay.
These are basically machine identities or service accounts that need to access and manage data.
So like the credentials that allow different apps to talk to each other.
Exactly.
Right.
So instead of storing these secrets in a central vault, they're dynamically derived using a similar approach to the keyless security model.
Got it.
This means that sensitive information always stays with the user, giving them ultimate control over access and decryption. They have something called an identity manager that handles all this deterministic key generation and management.
So it sounds like they've really thought this through.
Yeah.
Creating a system where the data, the keys, and the identities are all protected. But what about ransomware?
Yeah.
How does Pleon's Rail module protect against those attacks?
Remember how we talked about the data protection paradox?
Yeah.
How encrypted data is only as secure as the keys that protect it?
Right.
Well, Rail tackles this head on by focusing on encrypting the data while it's being used.
Wait, encrypting data in use?
Yeah.
How is that even possible?
It uses a technique called ephemeral block-based encryption.
Okay.
Only tiny chunks of data are decrypted at a time. And only within a secure, isolated part of the computer's memory.
Right.
So even if ransomware gets into the system, it can't access the entire file because most of it remains encrypted.
So it's like a moving target.
Yes.
The ransomware only ever sees a tiny glimpse of the data, never the whole picture.
Exactly. And to make things even more secure, they use short-lived keys. That are constantly being rotated. This is called forward secrecy.
Right.
It means even if a key is compromised, it can't be used to decrypt past or future data.
Wow, that's impressive. It sounds like they're creating a system where the data is always shifting and changing.
Right.
So it's really hard for ransomware to get a foothold.
Exactly. And to add another layer of protection, they have a module called ZTO.
ZTO.
It stands for Zero Knowledge Tokens.
Zero Knowledge Tokens.
Yeah.
What do those do?
Think of it this way. Instead of storing sensitive information directly, ZTO replaces it with secure tokens. These tokens act as stand-ins for the real data, and they can be used for things like authentication without ever exposing the actual sensitive information.
So even if someone steals a token,
yeah,
they can't do anything with it because it's just a meaningless placeholder.
Exactly. It's like having a secret code that only you can decipher.
Right.
To really understand this in depth.
Mm-hmm.
We need to look at Michael Combs,
yes,
BlockSmith founder.
The YouTube video, Keeping Secrets Safe.
Yeah.
I have to admit, some of the technical parts went over my head.
Sure.
But his passion for this stuff is incredible.
He's brilliant, and he uses a really interesting analogy to explain their approach to authentication.
Okay.
He connects Gabriel Kramer's theorem from the 1750s to the idea of keeping secrets safe.
I'm going to need you to break this down for me.
Okay.
Math is not my strong suit.
Essentially, Kramer's theorem states that to solve a system of equations with unknown variables, you need at least as many equations as unknowns.
Okay.
So Combs applies this to authentication by arguing that if you have, say, 5 public keys, you need at least 6 secrets to keep your data truly safe.
Okay.
This makes cracking the system mathematically impossible because the attacker will always be missing a piece of the puzzle.
So it's like trying to solve a puzzle with missing pieces.
Exactly.
You can never get the complete picture.
Right, and this is the basis of their N+1 secret principle.
Okay.
Always having one more secret than the number of public keys.
Right, the N+1 principle, it's about building in redundancy, so even if a few secrets are compromised, the whole system remains secure.
Exactly.
Now, his live coding demo,
yeah,
that was pretty impressive.
It was.
Even for a non-coder like me.
Yeah.
What was he trying to show with that?
He was showing how the N+1 principle works in practice.
Okay.
His code generated unique on-the-fly keys using a combination of factors, like a password, a seed, and a key ID. It was a way of showing that this abstract mathematical concept can actually be implemented in real-world code.
And he touched on some other interesting things, too.
Like what?
Password strength analysis. And the idea of treating passwords as binary data rather than just strings of characters.
Right.
I'm curious to learn more about how those things fit in.
Yeah, he emphasized that they're not just looking at the length or complexity of a password, they're analyzing its randomness to ensure that it's truly strong.
Got it.
And by treating passwords as binary data, they can explore a much wider range of possibilities for generating passwords.
It's all about pushing the boundaries of what's possible with password security.
Absolutely.
Okay, so we've covered a lot of ground here from the problem Pleon is solving to the specific modules and techniques.
Right.
But there's one more thing I want to touch on.
Okay.
Quantum resilience.
Right.
BlockSmith mentions this in their material.
Yeah.
And it sounds like they're thinking way ahead of the curve.
They are.
What's their approach to this emerging threat?
Their approach to quantum resilience is pretty radical.
Okay.
They call it anonymous security. And the idea is to make decryption produce plausible but potentially false data.
Okay.
So even if a quantum computer could break the encryption, the attacker wouldn't be able to tell which data is real and which is fake.
Wow, that's mind-blowing.
It is.
So instead of trying to build an unbreakable system, they're making the data itself untrustworthy.
Exactly.
They're introducing uncertainty.
Right.
It's a bold concept, and it's still very early in development.
It is.
But it highlights their willingness to really think outside the box and challenge conventional security.
Yeah, they're not just trying to stay ahead of the curve.
Right.
They're trying to redefine the curve itself.
Yeah, it's a lot to wrap your head around.
It is.
I'm wondering about the practical implications of this approach. How would it actually work in the real world?
Yeah.
And what kind of impact could it have on how we think about data security?
Those are all great questions.
Yeah.
And I think they lead us into some even deeper discussions about the future of cybersecurity.
Okay, let's do it. This idea of making the data unreliable to attackers. It seems like a fundamental shift in how we think about cybersecurity.
It is. It is.
Instead of just focusing on preventing access,
right,
they're considering the consequences if someone actually does get in.
Yeah, it's like a backup plan for the inevitable.
Right.
Instead of putting all your eggs in one basket, you're thinking about damage control as well.
But could that lead to data integrity issues for legitimate users?
That's a valid concern.
If the data is intentionally made unreliable,
right,
wouldn't that affect how it's used for legitimate purposes?
The challenge is implementing it in a way that doesn't impact legitimate use cases.
Okay.
You want to create that uncertainty for attackers, but still maintain data integrity for authorized users.
Right.
It's a tough balance.
It makes you wonder if this kind of thinking is essential as we move towards quantum computing.
Yeah.
I mean, traditional encryption methods might become obsolete.
Right.
If a quantum computer can crack codes that quickly.
Absolutely.
BlockSmith Anonymous Security, while it's still in its early stages, it offers a potential way forward, but it needs more exploration and refinement.
Absolutely. It shows their long-term vision
Right.
and their willingness to explore these new approaches to security.
Definitely.
But how does all of this translate into real-world benefits for businesses and individuals?
That's what I'm really interested in.
Yeah.
What difference does it make for people's daily lives?
Well,
for companies trying to protect their data?
From a business perspective, Pleon could significantly reduce costs.
Really?
Think about all the resources companies spend on managing complex security.
Right.
Dealing with password resets, responding to breaches, Pleon's streamlined approach to key management, password security, ransomware protection.
Yeah.
All of that could really cut down on those costs.
So it's not just about peace of mind.
Right.
It's about efficiency and return on investment.
Exactly. Exactly.
What about for individuals?
For individuals, it promises a more secure and less stressful online experience.
Okay.
No more remembering dozens of complex passwords.
Right.
No more worrying about your information being stolen.
That would be a relief.
It's about giving people control over their digital lives.
It sounds like Pleoni could be a real game changer.
It could.
But like with any new technology, there are bound to be challenges.
There are.
What do you see as the main challenges for them?
Well, adoption is always a challenge.
Right.
Especially for something that requires people to think differently about security. Businesses and individuals might hesitate to move away from familiar practices.
Even if they're flawed.
Even if they are, there's comfort in the known.
Yeah, I get that.
Even if it's not the most secure option.
So it's about overcoming that inertia, showing people that this new approach is better and easier.
Exactly. There's also the issue of integration.
Right.
Pleoni's modular design is great.
Yeah.
But it also means making sure all these different modules work with existing systems.
That's a good point.
It's one thing to have a cutting-edge security suite, but it's another thing to make sure it works with the stuff people are already using.
Okay.
Of course, there's also the challenge of staying ahead of the curve.
Right, because the threats are constantly evolving.
They are.
Attackers are always finding new ways to get in.
They are. BlockSmith needs to continuously innovate to stay ahead of those threats.
It's like an arms race.
It is.
Between those building defenses and those trying to break them.
Exactly. And this brings us to another challenge. Transparency and trust. Pleoni relies on these in-plex algorithms that most people don't understand.
It's like a black box.
It is.
You put your data in and you hope it comes out secure.
Yeah.
But how can people be sure it's actually working as intended?
Especially with something like anonymous security.
Right.
So BlockSmith needs to find ways to build that trust through transparency. Explain how it works.
Right.
Show evidence that it's effective. And be open to scrutiny from the security community.
It's about finding that balance between protecting their intellectual property, but also providing enough information so people feel confident using it.
It's a tough balance.
It is. They're essentially asking people to take a leap of faith, trusting that this new approach is really effective.
And that trust can only be built through open communication, rigorous testing, and engagement with the community.
Okay, so we've talked about Pleoni from a user's perspective.
Right.
But what about the developer side of things?
Okay.
The documentation mentions vaultless secrets and directory-less authentication.
Yeah.
Can you explain what those are?
Absolutely. These are key to Pleo's high level of security.
Okay.
Vaultless secrets means they avoid storing data in central repositories, which could be vulnerable to attacks. Instead, they use dynamic key derivation and encryption. So the secrets are only reconstructed when they're needed.
So instead of a central vault that could be a single point of failure, they're distributing the security burden across the entire system.
Exactly.
So each piece of data has its own unique protection.
Precisely. And directory-less authentication takes a similar approach. Instead of relying on traditional directories for user credentials, they use a decentralized model where authentication is handled on a per-key basis.
So it's more about verifying individual keys and permissions rather than checking a central list.
Exactly. This makes the system more resilient and adaptable.
Got it.
It reduces the attack surface and makes access control much easier to manage.
I can see how these choices contribute to Pleoni's overall security, but how do they actually implement these concepts?
They use a combination of cryptographic techniques, like hash functions, key derivation functions, symmetric encryption, all to create a system where secrets are never stored in plain text. That can be reconstructed on demand with the right combination of factors.
It's like a complex lock.
Yeah.
That requires multiple keys.
Right.
But the keys are never stored in one place.
Exactly.
They're recreated each time they're needed.
That's right.
That sounds incredibly secure.
It is.
But also very complex.
It can be.
Does that create challenges for developers?
Well, it's a valid concern, but BlockSmith has actually made Pleony pretty developer-friendly.
Okay.
They provide APIs and SDKs that abstract away a lot of the complexity.
Right.
So developers can integrate the security features without needing to be cryptography experts themselves.
So it's like a pre-built security engine.
Yeah.
That you can just plug in.
Exactly.
Without having to reinvent the wheel.
Right. It's about making security accessible and manageable for everyone.
It sounds like they're trying to make Pleony accessible to everyone, users and developers.
Yeah.
It's like they're trying to democratize security.
That's a good way to put it.
Making it something that everyone can understand and benefit from.
I like that.
But going back to that philosophical question.
Yeah.
If you can make data untrustworthy to attackers.
Right.
Does it even matter if they steal it?
That's the big question, isn't it?
It is.
I think BlockSmith is onto something really important here.
Okay.
They're recognizing that maybe the best defense isn't building impenetrable walls, but making the target itself less appealing.
Okay.
It's like a judo move.
I like that analogy.
Using the attacker's strength against them.
Right.
If they can't be sure they have the real data, does the equation of cybercrime start to break down?
That's a really interesting question.
It is.
Is it really a viable approach? Can you have a secure system and make the data itself untrustworthy?
Right.
And if so, what does that mean for the future of cybersecurity?
Big questions.
These are the things that I'm thinking about now. So it's like we're entering this new era of cybersecurity where the line between defense and deception is kind of blurred.
Exactly. It's not about just building those walls anymore. It's
Right.
about making the target less appealing.
Okay.
If they can't be sure they've got the real data.
Right.
The whole idea of cybercrime changes.
Does this shift the focus then from data protection to something more like data psychology?
Yeah.
I mean, it highlights that cybersecurity is as much about human behavior
It is.
as it is about technology.
Absolutely.
We need to understand how attackers think.
Right.
What they want.
Their motivations.
What makes the data valuable to them.
Yeah. And then use that to build defenses that exploit their weaknesses.
Turn the tables.
Exactly.
Make their job harder.
Right.
More uncertain.
As difficult as possible.
So if anonymous security really works.
Yeah.
Could it actually make some types of data less attractive to steal?
Potentially.
I mean, if an attacker knows.
Yeah.
They might not have the real data.
Right.
Even if they break the encryption, does it still have the same value?
It's like stealing a treasure chest.
Yeah.
And opening it up to find fool's gold.
Right.
The value diminishes.
It makes it less appealing.
Yeah, less of a target.
It's like those stories of pirates.
Oh, yeah.
Burying treasure. Creating maps with false trails and dead ends.
Right.
They weren't just protecting it. They were making it
too much trouble.
Way too hard to find.
Yeah.
Layered security. Not just technical.
It's psychological.
So if this takes hold.
Yeah.
Could it change the economics?
Interesting question.
Of cybercrime.
It's possible. If the cost and the risk outweigh the reward, we should see a decrease in certain types of attacks.
Okay.
But of course, attackers are always adapting.
Right. It's a constant back and forth.
It is.
We've talked about the benefits of anonymous security. But are there any downsides or risks?
One challenge is making sure legitimate users can still access the data.
Okay.
You want to create uncertainty for the attackers.
Yeah.
But you don't want to compromise data integrity for the authorized users.
It's about finding that right level of uncertainty.
Exactly.
Without affecting those legitimate use cases.
And there are technical challenges too.
Like what?
Making sure the system can handle all this extra data.
Right.
All this plausible but false data.
It's not an easy task.
Not at all.
So it sounds like it's still experimental.
It is, very much so.
A lot more research and development is needed.
Absolutely.
Before it becomes mainstream.
Yeah, it's a bold idea with a lot of potential.
But it's still early days.
It is.
Okay, so we've explored Pleony from its password and key management to its quantum resilience.
Right.
Really pushing the boundaries of cybersecurity.
They are.
They highlight some important trends, I think.
Definitely.
For the future of security.
What do you see?
Well, first, this shift from just defense to a more holistic approach.
Yeah.
That includes deception and resilience.
It's not enough to just build those walls.
Right. We need to make the target itself
less appealing,
less attractive.
Yeah.
Second, I think there's a growing emphasis on user empowerment.
Right.
Security needs to be designed with the user in mind.
Absolutely.
Easy to use.
Yeah.
Understand, manage.
Right.
And finally, collaboration.
Yes.
And transparency. We can't solve this alone.
We can't.
We need to work together.
We do.
Share information. build trust.
Absolutely.
Those are some important takeaways.
They are.
It sounds like the future of cybersecurity is going to be a lot more complex.
It will be.
More nuanced, more collaborative.
It has to be.
Than it is today.
Absolutely.
It's not just about technology.
Right.
It's about understanding people, adapting to new threats, and working together to create a more secure digital world.
I like that.
Well, this has been a really insightful deep dive.
It has been.
I feel like I've learned so much.
Me too.
About where cybersecurity is headed.
Yeah.
I'm sure our listeners have too.
I hope so.
And to our listeners, if you want to learn more about Preoni and the future of security, check out BlockSmith's website.
Definitely.
And Michael Combs' YouTube channel.
He's got some great stuff on there.
There's a lot of great information out there.
There is.
Dive in and explore.
The best defense is an informed one.
Stay curious, stay vigilant,
and stay safe.
Thanks for joining us on this deep dive.
It's been fun.
Into the world of cybersecurity.
Yeah.
We'll see you next time.
24.